Imagine, right, imagine going to the doctor for a broken arm, and instead of actually setting the bone, they just hand you a painkiller and say, take one of these every day for the rest of your life so it hurts less.
Right.
You'd think they were completely out of their mind. You'd find a new doctor immediately.
Oh, absolutely.
Yet for decades, that is like pretty much exactly how psychiatry has treated the human brain.
It really has. I mean, it's been a maintenance model through and through. The entire psychiatric paradigm was built around this idea of chronic symptom management.
Yeah.
The goal wasn't really to fix the underlying architecture of a mental health condition. The goal was just to keep your head above water, you know?
Yeah.
Just managing a chemical baseline day in and day out indefinitely.
But we are looking at a stack of clinical research today drawn from this massive, really comprehensive analysis called Escaping the Neural Prison. And it presents this radical paradigm shift. We are talking about moving completely away from chronic symptom management and stepping into this whole new world of acute neurostructural modification.
Which is, I mean, it's a profound redefinition of the stakes here. We are moving from treating mental illness solely as this fluid chemical imbalance that needs daily topping up to treating it as a structural problem, a literal physical architectural issue in the biology of the brain that can actually be repaired and remodeled.
So what does this all mean? How does a chemical like a pill or an IV infusion actually remodel a physical brain structure? That's our mission for this deep dive.
Yeah.
We are exploring how a very specific set of chemical catalysts, so we're talking psychedelics, dissociatives, and empathogens, are being used clinically to literally restructure the brain and break people out of these rigid cognitive prisons.
I want you to think about a time in your life when you felt completely stuck in a rut. You know that heavy, inescapable feeling where every single thought you have just circles back to the exact same negative conclusion?
Ugh, yeah, the worst.
Right. But what if that rut wasn't just an abstract emotional state? What if it was a literal physical groove carved deeply into the cellular biology of your brain?
Okay, let's unpack this, because before we even look at the specific catalysts themselves, we really have to understand what needs to be fixed. Like, what does that physical groove actually look like in a depressed or traumatized brain? And, you know, what are the biological tools required to pave over it?
Well, we have to look at the blueprint. And the central feature of that blueprint, particularly when we're discussing clinical depression, is this neural hub called the default mode network, or the DMN.
The DMN, yeah.
Right. And functional MRI imaging shows us that in patients with depression, this network becomes intensely hyperactive.
It's essentially the brain's idling system just going into overdrive.
Precisely. The research heavily implicates a hyperactive DMN in creating what they call rigid rumination loops.
Which is a very scientific way of saying you can't stop thinking bad thoughts.
Exactly. It is the biological manifestation of being trapped in your own negative thoughts. See, the brain is incredibly efficient. It always prefers to use the neural pathways that are already established because it saves energy.
Okay, when I read about the DMN and these rumination loops in the analysis, I immediately thought about sledding downhill covered in deep snow.
Oh, that's a good way to look at it.
Right. Because you take a sled down once and you leave a track. The next time you go down, your sled naturally wants to slide right into that exact same track because it's the path of least resistance.
Yep.
In a depressed brain, the DMN is like a sled track that's just packed incredibly deep in the ice. Every single thought you have just slides uncontrollably into the same miserable groove.
That visual captures the mechanical reality of it perfectly.
So to get out of the rut, you need a fresh blizzard. You need new snow to fill in that deep crack so you can actually steer the sled somewhere new. And in the brain, that fresh blizzard is a process called synaptogenesis.
Yes, the rapid growth of these tiny little branches called dendritic spines.
Right. And that is how the brain creates brand new neural pathways.
And the crucial protein that acts as the physical building material, the actual snow in your blizzard, if we stick with the analogy, is BDNF, or brain-derived neurotrophic factor.
BDNF.
Yeah, BDNF is essentially the master architect for neuronal remodeling.
And the escaping the neural prison analysis brings in some wild data here regarding how we actually trigger that BDNF.
If we connect this to the bigger picture, standard SSRIs, your everyday antidepressants, they actually do promote neuroplasticity.
Wait, they do?
They do. They lay down that fresh snow by utilizing BDNF. But And this is the key. An ill-life study from 2025 looked at psilocin. That's the active metabolite of psilocybin, the compound in magic mushrooms.
Right.
They found that psilocin binds to the specific receptor for BDNF, it's called the TRKB receptor, with a significantly higher affinity than standard SSRI antidepressants.
Meaning it binds tighter and hits harder.
Much harder.
Because standard SSRIs take weeks, sometimes months of daily chronic dosing just to accumulate enough fresh snow to even begin making a difference in that sled track.
Exactly. While these new chemical catalysts do it acutely, in a matter of hours or days, they trigger a massive, overwhelming biological weather event.
Which begs the obvious question, right? If BDNF is the fresh snow, how do we actually make it snow? We can't just swallow a snow machine.
Right.
We need to look at the classic disruptors, the classical psychedelics, specifically tryptamines and lysergamides.
So tryptamines are fascinating because structurally, they look incredibly familiar to the human body. Compounds like psilocybin and N-N-DMT possess what's called an indole ring structure.
An indole ring.
Yes. And this is essentially the exact same chemical architectural shape as endogenous serotonin, which is the neurotransmitter our bodies naturally produce.
So because they have that same shape, they basically fit into the same keyholes in the brain. They operate as potent agonists, meaning they activate the serotonin 5-HT2A receptors.
Right.
But the analysis points out these receptors are located primarily on cortical pyramidal neurons. Break that jargon down for me. Why does the location of these receptors matter so much?
Think of cortical pyramidal neurons as the primary broadcasters of the brain's outer layer, the cortex. They are these massive, complex cells that send long-distance signals to other parts of the brain.
Okay.
So when a tryptamine activates the 5-HT2A receptors on these specific broadcasters, it creates a cascading brain-wide disruption of normal signal flow.
And the clinical efficacy of that disruption is staggering. I mean, the research highlights phase 3 clinical trials concluded by Compass Pathways in 2025. They looked at treatment-resistant depression, or TRD.
TRD is remarkably tough to treat.
Yeah, these are patients who have tried multiple standard medications, therapy, everything, with zero success. And the trials showed that a single high-dose administration of psilocybin, paired with psychological support, caused statistically significant reductions in their depression symptoms.
One single dose.
One dose. And the neuroplastic window, that period where the fresh snow is on the ground and you can actually steer the sled somewhere new, stays open for weeks or even months following that one administration.
It's incredible. And we see similar, but actually even broader effects with lysergamides like LSD.
How so?
Well, LSD is a semisynthetic structural analog. But instead of just targeting the serotonin receptors like the tryptamines do, LSD has this broad spectrum binding profile.
It's more targets.
Right. It hits serotonin receptors 5-HT1A, 2A, and 2C, but it also crosses over and binds to dopamine receptors, specifically D1 and D2.
Oh, wow.
And this broad spectrum profile creates sustained cognitive flexibility, allowing the brain to literally build bridges over deeply entrenched trauma.
I have to push you on something here, though. I'm reading this, and I'm amazed that a single dose can have months-long effects. But if these tryptamines, like psilocybin, basically just mimic our natural serotonin, why doesn't our brain just do this on its own?
That's the big question.
If it's the same basic chemical shape, why do we need to bring in an external chemical catalyst to pry the plasticity window open?
That cuts right to the heart of evolutionary biology. It really comes down to intensity and function. While tryptamines look like serotonin, the way they bind to and activate those 5-HT2A receptors is uniquely potent.
Okay.
Our natural baseline serotonin levels fluctuate, sure, but they are strictly designed to keep us functioning within a stable, predictable range. The brain naturally, actively resists massive structural overhauls because, from an evolutionary standpoint, stability is safer.
Wait, so our brain actually prefers the miserable, depressed rut?
To the brain's base operating system, a known depression is safer than an unknown variable. The brain prioritizes known patterns over everything else. A depressed rut is viewed by our biology as a safe, predictable survival mechanism.
That is mind-blowing. Our own biology literally forces us to stay depressed because it's a known quantity.
Exactly. So what the external catalyst does is force an acute, overwhelming activation of those receptors. It is a violent override of that safety mechanism.
Wow.
It forcefully disrupts the default mode network, pushing the brain completely out of its comfort zone and triggering an intense state of plasticity that our natural endogenous systems just aren't programmed to initiate on their own. It does the heavy lifting that the brain's internal programming actively fights against.
That evolutionary perspective changes everything. It's an intentional system override. But as powerful as these classical psychedelics are, they operate primarily on the serotonin system, and they take hours of active experience, plus a lot of integration and psychological support.
You do, yeah.
Which brings up a critical gap in care. What happens when a patient is in an acute, life-threatening crisis?
Like active suicidal ideation.
Yes, you cannot ask someone in that state to endure a classical psychedelic session and wait for weeks of integration. They need an immediate intervention.
Right.
So the research shifts gears completely here. We move away from serotonin, and we look at the glutamate system.
This is where we introduce the rapid rescuer, ketamine.
Ketamine?
Yeah. Structurally and pharmacologically, ketamine is a totally different beast. It's an aryl cyclohexylamine, which classifies it as a dissociative anesthetic, not a classic psychedelic.
Okay.
And unlike the compounds we just discussed, this is legally available right now for psychiatric use. Doctors prescribe it off-label, and there is an FDA-approved nasal spray version called Esketamine under the brand name Spravato.
Now, the mechanics of how this works are wild, but the terminology is pretty dense. The sources state ketamine functions as a, quote, non-competitive NMDA receptor antagonist. Walk me through the actual mechanism without the jargon.
Sure. Picture the NMDA receptor as a massive dam holding back a river of a completely different neurotransmitter called glutamate.
Okay, got that, yeah.
Ketamine acts as a physical block on that dam. When ketamine blocks the NMDA receptor, the water has nowhere to go, so it triggers a massive downstream surge of glutamate.
It just spills over the top.
Yes, that flood of glutamate rushes over and aggressively activates a secondary set of receptors called AMPA receptors.
Here's where it gets really interesting. Because the AMPA activation acts like a rushing river turning a water wheel. And that water wheel is the mTOR signaling pathway.
What's fascinating here is what that mTOR factory actually produces. When the AMPA river turns the mTOR water wheel, it triggers rapid synaptogenesis.
There's that word again.
Right. But the key word here is rapid. We are talking about the physical generation of brand new synaptic connections within hours of administration.
Not weeks, not months, hours.
Exactly. When a patient is experiencing acute suicidal ideation, their brain is in a state of terminal rigidity. The sled track is so deep it feels like a grave.
God, yeah.
Standard SSRIs take weeks to achieve therapeutic concentrations. Ketamine provides an immediate neuroplastic intervention. It halts the crisis by forcing the physical growth of new synaptic connections in a single afternoon.
The difference in application is just profound. Like, if psilocybin is like hiring a contractor to slowly, meticulously remodel your house over a few weeks, bringing in new materials, thoughtfully redesigning the floor plan, ketamine is like calling the fire department to kick down the door and put out an active blaze immediately. It's a totally different therapeutic intention.
It is genuinely revolutionary for psychiatry to have a tool that operates on that timeline, to be able to say, we can physically alter the structure of your brain today to keep you safe.
It's incredible. So we've explored how ketamine works for acute internal crisis, and we've seen how the tryptamines break down internal rumination loops. But the analysis points out that the neural prison isn't always just about internal depression.
No, it's not.
What if the prison is built out of intense externalized fear? What if it's rooted in relational trauma, where the mere presence of another person or a specific traumatic memory triggers a massive physiological panic response? To dismantle that, we need an entirely different class of drug and a pathogen.
Now we are stepping into the territory of MDMA. 3-par-4-methylenedioxymethamphetamine. It's a substituted amphetamine functioning as an empathogen or entactogen.
Okay, what does substituted amphetamine actually mean behaviorally? Because when I hear amphetamine, I think of pure, jittery speed.
That is the crucial difference. The chemical structure of a baseline amphetamine has been altered or substituted in a way that changes its primary function.
Oh, I see.
Yeah, instead of just jacking up your heart rate and alertness, this specific structural substitution promotes intense feelings of emotional communion, empathy, and interpersonal closeness.
Its chemical profile acts like a symphony of neurotransmitters. MDMA triggers a massive acute release of serotonin, dopamine, and norepinephrine. But the real game changer is that it simultaneously stimulates the release of oxytocin, which is the neuropeptide absolutely critical for social bonding, trust, and empathy.
But flooding the system with trust and bonding chemicals is only half the process. The structural magic of MDMA is that it acutely reduces activity in the amygdala.
And the amygdala is essentially the brain's fire alarm.
Yes. When a patient with PTSD recalls their trauma, Their amygdala sounds a deafening alarm, flooding their body with adrenaline and terror. They literally can't process the memory because the alarm is too loud. MDMA dampens that alarm.
Building on that, if the amygdala is the fire alarm deafening you to reason, MDMA doesn't put out the fire. It puts heavy-duty earplugs into the patient's ears so they can calmly walk through the burning building with a therapist, point at the flames, and figure out how the fire started without suffocating from the smoke.
That allows for what psychologists call fear extinction within an exposure therapy framework. They can finally look at the memory without their brain's alarm system shutting down their cognitive functions.
And because of these prosocial effects, the clinical focus has actually expanded beyond just the individual.
That's right.
The sources detail how in 2026, institutions like Columbia University and the Multidisciplinary Association for Psychedelic Studies, or MAPS, advanced clinical trials using MDMA for dyadic therapy. Couples therapy.
Yes.
The pharmacological reduction of defensive reactions allows partners to sit down and process deep relational trauma, codependency, and communication gridlocks.
They can navigate those gridlocks with a baseline of profound chemical trust.
I have to play devil's advocate, though.
Okay.
If you flood two people with oxytocin, serotonin, and dopamine, of course they're going to get along. How do we know this is actual therapeutic healing and not just two people being chemically induced to artificially like each other for a few hours? Aren't they just high?
This raises an important question, and it's a distinction that therapists in this field emphasize heavily. It comes down to the concept of the therapeutic window. The oxytocin surge and the earplugs in the amygdala. The drug itself does not solve the couple's problems. The chemical does not do the therapy.
So it's not a magic love potion.
Far from it. What the compound does is lower the defensive walls just enough so that the couple, guided by a trained therapist, can actually do the grueling emotional labor that they are normally too terrified, too triggered, or too defensive to do.
I get it.
It creates a temporary ceasefire so the actual negotiations can happen. The healing comes from the communication and the processing that happens inside that safe container, not from the drug itself.
That distinction makes perfect sense. Though, it is important to note the regulatory reality of all this. The path forward is facing administrative hurdles.
It definitely is.
Impartially speaking, the sources note that in August 2024, the U.S. Food and Drug Administration issued a complete response letter rejecting the new drug application for MDMA-assisted therapy submitted by Lykos Therapeutics.
Right, and the FDA cited specific concerns regarding clinical trial blinding and data design.
Because of the subjective effects.
Exactly, because compounds like MDMA produce such obvious subjective effects, creating a true placebo-controlled double-blind study where neither the patient nor the therapist knows if they got the drug or a sugar pill is incredibly difficult.
Yeah, you'd know if you took it.
You really would. So as of the current research, MDMA remains limited to clinical trials while researchers work to satisfy those rigorous FDA evidentiary requirements.
It's a complex regulatory landscape, but the scientific momentum is undeniable. We've really covered some extraordinary ground today.
So we have.
We started with the serotonin-mimicking tryptamines, looking at how they violently disrupt the default mode network, paving over the deep sled tracks of depression with BDNF.
Right.
Then we moved to the lightning-fast glutamate surges of ketamine, turning the MTOR water wheel to physically grow new synapses in hours, saving lives in acute crisis.
Yeah.
And finally, the oxytocin-flooded safety of MDMA, putting earplugs in the amygdala's fire alarm so we can rewrite our deepest traumas and heal our relationships. It's abundantly clear that the future of psychiatry is shifting decisively toward neurostructural modification.
As we wrap up this deep dive, I want to leave you with a final thought to ponder.
Okay.
We've talked extensively about how these powerful chemical catalysts can successfully restructure the rigid, maladaptive neural networks of clinical populations, people suffering from severe treatment-resistant depression or debilitating PTSD. But if we are literally mapping the exact biological pathways to cognitive flexibility, what are the implications for the rest of us?
That's a massive question.
As this science progresses and the pathways become fully understood, will society eventually move toward a future of cosmetic neurology? Imagine a world where we use these chemical catalysts not just to heal severe clinical trauma, but to routinely upgrade our empathy, to deliberately dismantle our everyday biases, and to liberate our minds from the mundane, ordinary ruts of modern life.
It really makes you wonder, if we finally have the biological tools to pave over the sled track, why wouldn't you want to steer somewhere completely new?